between 2 and 3. So we're going to be talking about factoring out the greatest common factor today. So I think that the first question might be, what is a GCF? So a GCF is, again, just the greatest common factor. Let's do an example where we're just looking at two numbers. So if I am comparing the number, well, let's say like 15 to the number 20, in order to find the greatest common factor between these two numbers, I would need to know what the factors of the number are. So for 15, I could do 1 times 15. So those are both factors of 15. They both go evenly into 15. 3 and 5 are my other two options. So for 15, there are 4 factors: 1, 15, 3, and 5. For 20, I could multiply 1 times 20 to get 20, or I can multiply 4 times 5. And then I could also do 2 times 10. So for 20, there are 6 factors. As I look at the list of factors, I'm looking for what they have in common. It looks like the only ones in common are 1 and 5, but 5 is the largest one that they have in common. So 5 is the GCF for 15 and 20. Okay, that's just the common factor of two integers. But we are going to be looking at expressions, and we're going to be trying to factor out the greatest common factor. So what that really is it's the opposite of the distributive property. So for example, if I had 2x times x plus 3, I know that I would be able to use the distributive property to multiply 2x into the parentheses here. Each term would need to be multiplied by 2x. So that is the same as 2x squared plus 6x. Okay, so today, when we're factoring out the GCF, we're not going to be given our problem like this. We're going to be given our problem like this. We have 2x squared plus 6x. We need to factor out that greatest common factor. So in fact, we will be starting with this form, and we need to get back to this form over here, where we have that greatest common factor out front of the parentheses, and then we have what's left inside. So let's start with an example. If I have, for example, say 18x squared plus 9x. Okay, I want to factor out the greatest common factor. So I want to see what, first of all, these two numbers have in common. What's the greatest common factor between the two numbers? But then I'm also going to be comparing the x's. So for 18 and 9, I know that the greatest number that goes evenly into both 18 and 9 is 9. So I will be pulling out a 9. If you can't see right away what the greatest common factor is, we can do what we did up here previously and write out all those factors and then just look for the biggest one that they have in common. I know that 9 times 2 is 18. So I'm going to write that here. I'm just kind of factoring everything out. So x squared, that means x times x. Right, so I'm just expanding this. Because 9 was the greatest common factor, I'm pulling a 9 here. Over here, I'm going to just write 9 times x. So I'm looking for what's in common. That's what I'm going to pull out front. So I've got the 9 here and here. And since it's in both expressions, I can pull it out in front of my parentheses. Then I'm looking at the x's. I have 1 in common here and here, so I can pull out 1x. But I can't pull out more than 1, because although this term has more than 1, the second term does not. So the only thing left in our first term here is 2x. In my second term, everything factored out, but I would still have a 1 there. Remember, I'm basically dividing each of these terms by 9x to see what's left over. If I divide 9x by 9x, I get 1. So now here we have the factored form. We have 9x times 2x plus 1. Now you can double check this each time to see if you did it correctly. The answer is here. I've put it in a box. I'm actually done. But if you want to double check and make sure that it is the correct answer, you can go ahead and multiply that 9x back into the parentheses quickly and just make sure you get the same thing back. again, I already have the answer here. I'm just double checking to see if my answer is correct. So if I multiply 9x times 2x, I get 18x squared. And if I multiply 9x times 1, I get plus 9x. So 9x times 2x plus 1 is the correct answer for factoring out the greatest common factor. All right, let's do a couple more examples here. All right, so we're going to go ahead and do a couple more examples here. So if I have something like this, so let's say I have x squared plus 14x, and I'm looking to pull out the greatest common factor. Remember that x squared, if I don't see a number in front of it, the only number in front of it is a 1, right? So there's really no number that I can pull out here. There's no, besides 1, which is just kind of redundant. I don't need to write 1 out here, right? But if I'm looking at my x's, I have x times x here plus 14 times x here. So because I do have one x in common, that x can be pulled in front of the parentheses because x plus 14 will be multiplied by x. So x times x plus 14 would be the factored form of x squared plus 14x. If I have something like this, let's say 10x squared plus 25x. Now I have 10 and 20. I need to find the greatest common factor of 10 and 20. The number that goes evenly, the biggest number that goes evenly into both 10 and 25 is 5. So I'm going to write this as 5 times 2 times x plus 5 times 5 times x. Now the biggest number they both have in common is the 5. So I'm going to pull the 5, and also they have one x in common, so I'm going to pull the x. Nothing else here matches, and so these other things will have to stay inside the parentheses. So the 2x stays inside, and the 5 stays inside. So here is the factored form of 10x squared plus 25. Again, quickly double check, make sure if I were to multiply this back through, that I would get the same thing that I started with, which it looks like we're okay there. All right, let's try 3x to the third plus 6x. All right, so 3x cubed plus 6x squared plus 12x. So we need to find the common factor between all three of these numbers, 3, 6, and 12. So the greatest number that goes evenly into 3, 6, and 12 is 3. So I'm going to write this as 3 times x times x times x. And because 6 divided by 3 is 2, I'm going to write 6 as 2 times 3 times x times x. And 12 is 3 times 4 times x. So 3 is that greatest common factor in the numbers, and then we have one x in each term. Let's circle the 3's too. So 3x will be my greatest common factor. That's what I'm pulling out front. Then I'm just seeing what's left in each term. So in the first term, I just have x times x, which is x squared. In the second term, I have a 2 and an x. And then in the third term, I have just a 4. So the factored form of 3x cubed plus 6x squared plus 12x is... All right, so now we're going to shift gears just a little bit. The last part of your assignment for today is going to have something like this. It says, if m equals 15 and s equals 8, we're going to find two numbers that when I multiply them together, so if I multiply them, they're going to equal m. M for multiply, 15. So find two numbers that multiply to 15, and they add or sum to 8. So remember, add and sum mean the same thing. So find two numbers that multiply to 15 and sum to 8, or multiply to m and sum to s. So the first thing we need to do is just look at m. We need to find numbers that will multiply to 15. So I have some options. I have 1 times 15, or I have 3 times 5. For 15, there are no other options. But I need these two numbers to add or subtract to 8. 1 plus 15 is 16, and 15 minus 1 is 14, so that one is not going to help me now. 3 plus 5 equals 8, so these are the two numbers I was looking for. So 3 and 5 both multiply to 15 and sum to 8. So the reason that we're looking at these is because this is going to help us in our next section where we begin to learn how to factor quadratics. We'll talk more about what that means later. So let's try it again. So let's try to find two numbers that multiply to 6 and sum to 7. Okay? So numbers that multiply to 6 would either be 1 times 6 or 2 times 3. Since 1 plus 6 equals 7, this is the one that we want. So 1 times 6 equals 6, I should say, and then 1 plus 6 equals 7. So the two numbers that multiply to 6 and sum to 7 are 1 and 6. So let's try a couple more. If I have m equaling negative 14 and s equaling, let's say, negative 5. Okay, I need two numbers that are going to multiply to negative 14 and sum to negative 5. So the options for 14 are 1 and 14, or 2 and 7. Now I know that one of these numbers has to be negative because 14, the result is negative, right? And if I multiply two numbers together and get a negative, that means one of my original numbers would have been negative. So I'm looking for two numbers that multiply to 14 and sum to 5. I know one of the numbers has to be negative. It doesn't look like 1 and 14 is going to help me because 1 plus 14 is 15 and 14 minus 1 is 13. So the only two numbers I could get are 15 and 13 for that one. For 2 and 7, if I add them together, I'm going to get 9. But if I subtract them, I would get 5. So 2 and 7 will work. I just need to decide which one should be positive and which one should be negative. Now if I do negative 2 plus 7, that's going to give me a positive 5. I don't want positive 5. I wanted negative 5. So instead I'm going to do a positive 2 plus a negative 7. That's going to equal negative 5. So those are the two numbers that I wanted, 2 and negative 7. All right, let's try that one more time, just one more example. If m is equal to negative 590 and s is equal to 49. Okay. So we have some pretty big numbers here. I'm going to start by just starting to list them. So 590 and 1 multiplied 5. I'm going to ignore the negative for a minute. I know eventually I'll have to decide which number will be negative and one of them will need to be. But right now I'm just trying to find numbers that multiply to 590. So I've got 1 times 590. I've got 2 times 250 or 295. Let's see, will 3 go into that? No. But you get the idea. You can just get your calculator out and you can divide numbers. Let's see what 590 divided by 4 is. If 590 divided by 4 goes in evenly, I know it goes in, but it doesn't. That gives me 147.5. So 4 is not going to work. Let's try 590 divided by 5. That's 118. So 118 times 5 would work. But I'm trying to get 49, so I know my number's going to need to be a little bigger. It looks like 10 will go in to 590. times 59 would give me 590. And I see that the difference between 59 and 10 is 49. So what I'm going to do here is I'm going to decide which one of my numbers should be positive and which one is negative, because these two numbers here will work. They do multiply to 590 and they do add to 49 if one of the numbers is negative. Since 49 is positive and that's the bigger number, I'm going to leave 59 positive and make 10 negative. So 59 minus 10 does equal 49. So the two numbers that work, that make 590 when you multiply them, or negative 590 when you multiply them, and 49 when you add them, are 59 and negative 10. Alright guys, tune in later today for questions and answers on this section. Try the problems first, get out the worksheet, give it a try, and then if you have questions, please join us at 2 o'clock in your Zoom app, and we will see what we can do. Thank you. Bye.